Ladies and gentlemen, this is Miss Humbert here, and today we're going to be doing Unit 1 Notes of 8. So we're going to be talking about angle measures. So we're going to start working with angles. So let's go ahead and let's take a look. Taking a look at this first part, just some definition stuff. So a ray is a part of a line with one endpoint. So there's one part of it that's going to terminate, and the other point that extends infinitely in one direction. So first thing we're going to do is just draw some rays on this side. So I'm going to draw this ray right here. Then I'm going to draw this way right here. So notice that it stops right here and that it stops right there. Okay, so want to look at the symbolic representation. So when we do a ray, what we're going to do is pick two letters, so like YT, that are on the ray, and then we're just going to draw an arrow going in one direction. So we're kind of drawing a ray over it. So SX, drawing a ray over it, and so forth. So that's how you would do a ray. Now let's take a look at an angle formed by two non-collinear rays or sides that meet at a common point. So here what we're going to do is we're basically going to take two rays and they're going to connect at point C. So the sides of the angle are rays. So we would name those sides CA. I usually like to write the vertex first. That's just my preference. And then the vertex. So the vertex of the angle is just a point. So I'm going to call that point C. So that's my kind of chart for A. Now let's take a look at some more things that we're going to need to know for angles. The angle divides the plane into three distinct parts. So points C, B, and D lie on the angle. So you notice that C, B, and D are directly on the angle. Okay? Then point A lies in the exterior of the angle. So if you'll notice, point A is on the outside of the angle. No matter how far you stretch our angle B or CBD, it's never going to reach point A. So we say that point A is on the exterior. Then point E is on the interior. Okay, so then that means that it's going to be inside of kind of the mouth of that angle. So that makes it interior. So let's go ahead and let's take a look at some of these. Name a point on the exterior of DEB. So the first thing I want to do is find the angle DEB. So DEB is this angle right there. So we want to find a point on the exterior, so somewhere that's not going to reach. So F is a point that's not going to actually reach inside of the angle, and so is G. Okay? Taking a look at number 2, name all of the angles that have B as a vertex. So let's go ahead. So here is B right there. There is my B. And we want to find all the angles that have it as a vertex. So I have this angle right here. So when we go to name that angle, what I'm going to do when it's letters is I write the letters, and I always put the vertex in the middle. So I would call that angle ABG. So then we have this angle here that doesn't necessarily have letters, but it has a number. So I can call that angle 7. So if it's just a number, then you can name it by just that number. Also, angle 6, and just like this, angle 5. Next, it wants us to name the sides of angle 5. So let's go ahead and highlight angle 5, which is right here. So one of the rays is going to be GB. So I'm going to write the letters GB, and I'm going to put a little arrow over it. Next, I'm going to have BE as a ray, so I'm going to write BE, and I'm going to put a little arrow over it. Okay. Last but not least, what is another name for angle 7? So angles can be named by letters or numbers. So we already used the numbers, so we're going to have to name it by letters. So we have the letter A, B, and D. Okay, so we have the angle, and so what we're going to do is use the letters. So the vertex, since that's B, is going to be our center. So that's going to be angle ABD. So let's go ahead and take some look at more different types of angles. So we want to classify each angle. So notice this square down in the little corner of the angle. Whenever you have a little square in the corner, that means that it is a 90-degree angle. So that's whoops, I put it in the wrong spot. Come on, Humbert. So 90-degree angle is here, and the type of angle is a right angle. Now this little guy here, notice that it's less than 90 degrees. It's going to be smaller than this angle over here. So when it's less than 90 degrees, it's acute, or as I like to say, acute angle, because it's little and it's cute. So the measure is going to be less than 90 degrees. So any angle that's less than 90 degrees is acute. Then notice that this one is going to be larger than the 90-degree angle, so that's going to make it obtuse. And so since it's larger than 90 degrees, its measure is obviously going to be greater than 90 degrees. Last but not least, this one is just a straight line, so I'm just going to write it as a straight angle. And its measure is going to be 180 degrees. So whenever you have a straight line, it's 180 degrees. So let's go ahead and let's take a look at 5 and 6. So we need to classify each angle as acute, right, or obtuse. So first is the angle SYT. So I'm going to follow S to Y and then up to T. So when I look at that angle, it looks to me like it's smaller than 90 degrees. So that's going to make it an acute angle. Then, taking a look at number 6, what we want to do is do SYX. SYX. So that's talking about this whole big angle right there. So if you'll notice, that whole big angle to me looks like it's larger than 90 degrees. So then that is going to be obtuse. Okay. So then, taking a look at this next one. So an angle bisector is a ray that splits an angle into two other congruent angles. So do you see how each of these have one line? So if they have one line each, that's our way of saying those two angles are congruent. Also, if they both have two arcs, that means anything with the two arcs is also congruent. So how would we write that? Remember that the congruent symbol looks like this. That means congruent. So it's an equal sign with a little squiggly on top. So what we would say is angle WXY is congruent to angle YXZ. So I go WXY to name it, and for this one I go YXZ to name it. So that would be the congruent statement for that angle bisector. Now let's take a look at number 5. So it tells us that KN bisects JKL. So here's JKL. So since KN bisects it, that means that these two are equal length. If the measure of JKN, so that's this piece, is 8x minus 13, and the measure of NKL, that's this angle, is 6x plus 11, find JKN. So that doesn't mean I'm just going to write AX minus 13 as my answer. What I'm going to do first is find out what X is equal to. Well, since both of these angles are congruent, I'm going to go ahead and I'm going to set them equal to each other. And then we're going to solve for X. So I'm going to go ahead, since that's a positive 6X, I'm going to subtract 6X from both sides, and then I get 2X, then minus 13, and that's going to be equal to 11. So I'm going to go ahead and add 13 to both sides. So I get that 2x is equal to 24. So since that 2 is being multiplied by the x, I'm going to go ahead and divide both sides by 2, and I get that x is equal to 12. So now that I know that x is equal to 12, I'm going to take a look at JKN. Right here, well, JKN is represented by 8x minus 13. So what that means is I need to rewrite out that expression, and instead of writing x, I'm going to substitute 12 in instead. So I have 8 times 12 minus 13. Well, 8 times 12 is 96, and minus 13, we're going to get 83 degrees. So the measure of angle JKN is going to be equal to 83 degrees. Now, when we're talking about a measure of an angle, it's always in degrees. That's the label that we're going to use. Let's take a look at this one. QS bisects the angle PQT. Now what you're going to find in geometry is sometimes it's really hard to visualize things, so I like to draw a diagram. So I'm going to call this P, my vertex is Q, and this is going to be T. So that's my angle, and it's going to bisect with QS. So that's going to be S right there. Okay, so since it bisects, that means that both of those are equivalent measure. PQT, that's this whole angle right here. The whole angle itself is going to be 6x plus 4. Then it tells me that TQS, this little guy right here, is 7x minus 2. And we need to find PQT, so the big angle measure. You're probably like, oh my gosh, Ms. Humbert, this is so confusing. Well, remember that this is bisected, so if this guy right here is 7x minus 2, then this guy right here is also 7x minus 2. So then what we're going to have is 7x minus 2 plus 7x minus 2, and that's equal to 6x plus 4. So now let's go ahead and solve this, because notice that the two of these together make up the whole angle. So that's why we can add them together and set them equal to 6x plus 4. Well, 7x plus 7x is 14x. Negative 2 plus negative 2 is negative 4, and that's equal to 6x plus 4. So the next thing I'm going to do is subtract 6x from both sides. Well, 14x minus 6x is going to give me 8x. You always want to have your x's on the same side. So then I'm going to go ahead and I'm going to add 4 to both sides to keep solving for that x. Well, 4 plus 4 is 8. 8 times x, well, we need to divide both sides by 8, and we get that x is equal to 1. So now we know that x is equal to 1, but that's not what the question is asking us. We're supposed to find the measure of PQT. So PQT is the big angle, and PQT is equal to 6x plus 4. So now we need to plug in what we know x is. So the measure of angle PQT is equal to 6, and then we're going to take out the x and put 1 in instead, plus 4. 6 plus 4 is 6, plus 4, or 6 times 1 is 6, plus 4 is 10. So the measure of that angle is simply 10 degrees. So that concludes your note video for today. Show me your note sheet when you're done. Thanks for listening.